Hello guys, in this video we are going to discuss the solution of the problem count pairs sum in matrices. So let us look at the problem statement. The problem statement says that given two sorted matrices mat1 and mat2 of size n by n of elements, each matrix contains numbers arranged in strictly increasing order with each row sorted from left to right and the last element of the row being smaller than the first element of the next row. You are given a target value x. Your task is to find and count all pairs AB such that A is from mat1, B is from mat2, where sum of A and B is equals to x. So let us try to understand the problem statement with the help of an example. So here n is equals to 3, which simply means we are given two matrices mat1 and mat2 of dimension 3 by 3. The matrices which is given is in strictly increasing order. So 1, 5, 6, 8, 10, 11 and so on. So as you can see, this matrix is in increasing order. Similarly, the matrix 2 is also in increasing order. A number x is given to us which is 21 and our task is to find an element from mat1 and an element from mat2 such that the sum of those two elements becomes equals to 21 and we need to count all such pairs. So for instance, in this matrix, the number of such pairs are 1 and 20, 5 and 16, 8 and 13 and 11 and 10. So the total number of pairs which we have is 4, thereby we are returning 4. So that's about the problem statement, folks. Now let us discuss the solution for this problem. So let us take an example in order to discuss the optimal solution for this problem. So here n is equals to 3 and x which is given to us is 21 and matrix 1 is, so this is matrix 1 which is given to us and this is matrix 2 which is given to us. Now given these two matrices, we need to find out the number of pairs such that the sum is 21. So in order to understand the solution, what we are going to assume is rather than the data which is given to us in the matrix form, it is given to us in an array form. So basically what I'm trying to say is that let us assume for a moment that the data of matrix 1 is in a single dimensional array and we can construct an array such that all elements are here. So the elements of the matrix are arranged in the array in something of this format. Oh, sorry guys, this is 18. So let me just have it as 18. So this is 18. So matrix 1, we can just assume it for the moment in order to understand the concept that matrix 1 is something of this format in array 1. Similarly, matrix 2 is in array format, single dimensional array format, and we can arrange matrix 2 in this way. So in this way, I have arranged matrix 1 and matrix 2 in array format in a single dimensional array format. Now, in order to find out the number of pairs such that the sum is equals to 21, what all we have to do is we need to have a pointer I equals to 0 and j is equals to n minus 1. So let us say here since 3 by 3 matrix, so that n will be equals to 9. So j we are going to set it to 9 minus 1 which is equals to 8. So what I'm trying to say here is I is here, this is my I and j is here, right? Now what we are going to do is we are going to compute the sum of ARR1 I plus ARR2 j. So if we compute the sum of I and jth element and if we compare that the resultant sum with x, then one of these three conditions will be satisfied. So let me call this, let us say that we are storing it in a variable x, the sum of these two elements. Now y can be equals to x, so that is my first case. Y could be greater than x, otherwise y will be less than x. So let us see what we are going to do in each of these cases. So let us first discuss the case where y is greater than x. So y is greater than x simply means that ARR1I plus ARR2J is greater than x. So since it is greater than x, so what we would like to do is we would like to decrease this value, right? This resultant value we would like to decrease it such that it becomes equals to x. Now, since the array are sorted in nature, if we pick the next element of first array, let us say we go ahead and pick the next element of first array. Now, if we go ahead and pick the next element of first array, then we know that since the array is in increasing order, so we know that ARRI is less than ARR1I plus 1. So what I am trying to say is the sum, if we go ahead and increase the first element, the sum will increase, right? And our objective is to decrease the sum. So thereby, if we want to decrease the sum, we need to go ahead and decrease our jth counter. So to decrease the sum, we have to go ahead and decrease our jth pointer. Conversely, if we want to increase our sum, so that will be this case. So if you go ahead and look at the case where y is less than x, where y is less than x, so here essentially what we meant is ARR1 ith element and the sum of jth element is less than x. So in order for this to become equals to x, we have to increase our sum, and to increase our sum we have to pick the next element from the first array. To increase the sum, we need to pick the next element from first array. So let's go back and summarize what we have learned so far. So here we know that the sum is greater than x, in which case I need to decrease the sum, and in order to decrease the sum I need to decrease jth pointer. Please note, jth pointer points to the second array. Similarly, if I have to increase my sum, I need to increase ith pointer. And in the case where the sum is already equals, we will go ahead, increase our ith pointer and decrease jth pointer. And so essentially now I'm picking the next element from first array and picking a next element from the second array, and then again I'll go ahead and compare the sum with x, and one of these three conditions will hold and we will go ahead and perform this logic till we have exhausted all the elements of the array. We will go ahead and increase our count pointer, and towards the end this is what we are going to return. So that's the general idea, folks. Now if we want to achieve the same thing in matrix, the only thing which we need to worry about is how are we going to increase and decrease our jth or ith pointer. Because in single dimensional array it is very easy, I plus 1 or j minus 1 is what we are doing. But in a two dimensional array, since there is I and j, so that is the only thing which we have to worry about, and the rest of the logic remains same. So now let us discuss how we are going to go ahead and increase and decrease ith and jth pointer in a two-dimensional array. So let us say I would like to increase my ith and jth pointer, and let's say this is the dimension which is given to us. So essentially what this function does is, I am at some position I comma j. Now I want to pick the next element. Right, so let us see how we can pick the next element. So here, in order to pick the next element, I just have to increase my j to j plus 1, right? But it might be possible that j exceeds the window of n, in which case I needs to be increased too. Let us see how we will be able to achieve this. So what we are going to say is, if j plus 1 is less than n, which simply means it is well within the window, then the final I remains I. We don't have to do anything with I, and the final j will become equals to j plus 1 since it is well within the window. If it is not well within the window, then rather than increasing j, we are going to increase I by 1, and we are going to set our j to 0, right? So for instance, if you want to understand it through an example, let us say n is equals to 3, and initially we are at position 1 comma 1. So the next element will be 1 comma 2. So here we have increased just j, which is the first case. Here j plus 1 is well within the range of n, because of which I have not touched I remains as it is, j is what I have increased it by 1. Whereas in the second case, if you see, let us say we are at position 1 comma 2. So here if we go ahead, the next element will be 2 comma 0, right? Because this is at the window, or this is the last element of the first row. So the next element will be my first element of the next row, which is 2 comma 0, which is what I have handled over here. Similarly, in the case we would like to decrease I comma j, how we are going to do it is, so we are going to check if j minus 1 is greater than or equals to 0. So if it is greater than or equals to 0, then we are well within our range, and we are going to simply go ahead and decrease our j, and the I remains as it is. Otherwise, what we need to do is we need to decrease our I by 1, and j we need to set it to the last element, which is n minus 1. So that's how we will go ahead and increase and decrease our pointer, and the core concept remains the same. So with these two understanding, let us see how we will be able to code this. So this is the core logic, folks. We have 4 pointers with us: I1, J1, I2, J2, and I1, J1 are set to 0, and I2, J2 are set to the last element. Now we will iterate on all the elements of the matrices till this condition is satisfied. We are going to compute the sum of the elements of matrix 1 and matrix 2. If it is equals to x, then we will increase our count pointer by 1, and we will go ahead and increase and decrease our I and j. If the sum is greater than x, so we would like to reduce our sum such that it becomes equals to x. So in order to reduce our sum, we need to go ahead and decrease I and j of matrix 2. So that is what we have done over here. Otherwise, we need to increase our I and j of matrix 1, and towards the end we will go ahead and return count, and that will be our answer. Now let us look at how I and j was manipulated. So to increase I and j, as we have discussed, this is how we are increasing I and j, and similarly this is how we are decreasing I and j. So that's about the code, folks. Now let us go ahead and submit our solution. So our solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.